Welcome to this SAT Algebra review. Today we will review the fundamental concept of the slope of a line in the coordinate plane, then walk through 10 practice problems focused on finding the slope of a line. The examples will gradually increase in difficulty, therefore feel free to skip ahead if you want to. There are 3 equivalent mathematical representations of slope of a line using coordinate geometry. Using coordinates of 2 points on the line, the slope is defined as the ratio between difference in y-coordinate and difference in x-coordinates given that the horizontal coordinates are not equal. Second representation of a slope of a line is the ratio of rise to run, highlighting the vertical movement relative to the horizontal movement between 2 points on the line. Lastly, the slope could be represented as the ratio of the overall change in the vertical variable y, divided by the corresponding change in the horizontal variable x. In this first example, we are asked to find the slope of line in the xy plane which passes through 2 points 3, -5 and -2, 5. To find the slope of a line, we can use the standard slope formula. M equals y2 minus y1, divided by x2 minus x1. Now we substitute our given coordinates into the formula. Simplifying this expression, we get 10 over -5, which reduces to -2. The slope of line L is -2. Therefore, option A is the correct answer. In the second example, we will learn how to find the slope of a line directly from its graph. Given the graph of line L in the xy plane, we need to determine which of the given choices is the slope of line. First, looking at the graph, we can identify 2 coordinate points through which the line passes. Here, 2 points are clearly labeled for us, 0, 2, and 3, 4. Like in previous example, we can apply the slope formula. Plugging in our points, we find that slope is 2/3. Comparing this to our choices on the left, we find that the correct answer is option A. In this example, we are asked to find slope of a linear function using a table of values. For any linear function, the rate of change, or slope, is constant. We can calculate this slope using the rate of change formula, which equals the difference in function values divided by the difference in the input values. To begin, we can choose any 2 points from the table. Let's select the first 2 coordinate pairs, 2, 11, and 5, 23. Substituting these 2 points' values into slope formula above and simplify, we get that slope of the line given by the table values is 4. In this example, we will find the slope of a line starting from its standard form equation. The problem states that a line is represented by equation 3x minus 4y equals 12, and it asks to find the slope of this line. To find the slope, we can convert this equation into slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept. Let's begin with the given equation, 3x minus 4y equals 12. First, isolate the y term by subtracting 3x from both sides. Next, divide every term by -4 to solve for y. In slope-intercept form, the coefficient of x is the slope m. Here our slope is 3/4. Looking at the options on the left, this corresponds to option C. Now, we will determine a missing constant in a system of linear equations that has no solution. We are told that this system has no solution, and we need to find the value of the constant A. For a system of linear equations to have no solution, the lines must be parallel, which means they have equal slopes. To find these slopes, we can rewrite both equations in slope-intercept form. Let's start with the first equation, ay minus 3x equals 8. To isolate the y term, we add 3x to both sides, then divide all terms by a. The slope of this first line, m1, is 3 over a. Now, let's look at the second equation, 2y minus 5x equals 12. Adding 5x to both sides, then divide all terms by 2 gives us the slope of 5 over 2. Because the lines are parallel, we set the two slopes equal to each other to solve for a. This gives us the proportion 3 over a equals 5 over 2. To solve, we cross-multiply, obtaining the equation 5a equals 6. Finally, dividing both sides by 5 yields a equals 1.2, which can also be written as the fraction 6/5. This gives us our correct answer of 1.2 or 6/5. Now, we will solve for a missing constant in a system of linear equations that has infinitely many solutions. For a system to have infinitely many solutions, both equations must represent the exact same line. This means their coefficients and constant terms in standard form, ax plus by equals c, must be proportional. Let's express both starting equations as standard form. To compare them directly, we can manipulate one equation so that the constant terms align. Since the first equation ends in 12 and the second ends in 6, we can multiply the entire second equation by 2. Since the x coefficients and the constants are now identical, their y coefficients must also be identical. We can conclude that b must equal 6. This matches option D, which is our correct answer. In this example, we will determine a missing coordinate of a point using the properties of parallel lines. Our problem states that in the xy plane, line L passes through the points 2, 5, and 6k. If line L is parallel to the line y equals 3x minus 4, we need to find the value of k. First, recall that parallel lines have equal slopes. This means the slope of line L will be the same as the slope of the given line. The given equation is already in slope-intercept form with its slope equal to 3. Therefore, line L must also have a slope of 3. Next, we use the slope formula with the 2 points on line L, 2, 5, and 6k, and set it equal to 3. To solve for k, multiply both sides of the equation by 4, and then add 5 to both sides. The correct answer is 17. In this example, we will learn how to determine the slope of a line that is perpendicular to a given line. Let's look at the question. In the xy plane, line P is perpendicular to the line with the equation 2x minus 5y equals 10. We want to find the slope of line P. To begin, we need to find the slope of the given line by converting its equation into slope-intercept form. Starting with the given equation, we subtract 2x from both sides, then we isolate y by dividing every term by -5. From this form, we can identify that the slope of our given line is 2/5. Recall that perpendicular lines have slopes that are negative reciprocals of one another, expressed as m perpendicular equals -1 over m. To find the slope of line P, we take the negative reciprocal of our initial slope 2 over 5, which gives us -5 over 2. This matches option A, which is the correct answer. In this example, we will learn how to interpret the slope of a linear function within a real-world context. Let's look at this problem. A computer technician charges a one-time diagnostic fee plus a flat hourly rate for repairs. The total cost, C of H, in dollars for a repair that takes H hours is given by the function C of H equals 75 plus 45H. We want to find the best interpretation of the slope of this function's graph. To begin, we can analyze the structure of the function. The given equation is a linear function in slope-intercept form. C of H equals mh plus b. Here, m represents the slope or rate of change, and b represents the y-intercept, which often corresponds to a starting value or one-time fee. Comparing this general form to our given equation, C of H equals 75 plus 45H, we can identify the slope. The coefficient of our variable h is 45, meaning our slope, m, is equal to 45. In this real-world context, the slope of 45 represents the rate of change of the total cost with respect to hours. In other words, for each additional hour of repair, the cost increases by $45. This tells us that the slope represents the hourly rate of $45 charged for repairs. In the last example, we will explore an application of the slope formula in coordinate geometry. Let's look at the problem. A line in the xy plane has a slope of -3/4 and passes through the points A7 and A plus 8b. We want to find the change in the y coordinates, represented by the expression b minus 7. We can begin by using the standard slope formula, which is m equals y2 minus y1, divided by x2 minus x1. Next, we substitute our known slope and coordinate points into this formula. To isolate our target expression, b minus 7, we can simplify like terms, then multiply both sides of the equation by 8. Thus, the change in the b minus 7 is -6.